Let's switch to cybersecurity, the second out of the four core areas. Cybersecurity has to do with protecting your system from losses caused by malicious actors. The security properties vary by application. In the information technology world, in the normal everyday enterprise computing world, we tend to care about confidentiality a lot. We're worried about people stealing your password, stealing your credit card, and so on. And encryption is the typical technology used for that. But in the embodied AI world, if you have a robotaxi, while privacy does matter, everyone can see the car on the road, everyone can see you turn left, you turn right. So the confidentiality is less of an issue, and more of an issue is integrity and availability. You want to make sure that no one has modified the software to make it unsafe, and you want to make sure that the safety functions associated with mitigating risk remain available so that you don't have a loss of safety. There's an emphasis on safety, integrity, and availability rather than confidentiality. If somebody says their embodied AI system is safe because they use encryption, ask them about integrity and availability, because encryption helps with confidentiality, but not necessarily with other properties. One useful way to look at security attacks for embodied AI systems is that they're malicious faults. If you care about safety, cybersecurity attacks are a way that faults can occur that you thought probably wouldn't happen if you were just thinking about safety. For example, an attacker might introduce a fault missing from the hazard analysis, or they might violate a safety analysis assumption. You may have said a particular hazard is extremely rare, so you're not going to worry about it. Well, then the attacker's job is to find a way to make that hazard happen frequently instead of rarely, and therefore induce a safety problem into your system. A big problem with embodied AI systems in particular is that the attacker often has physical access to your system. If you have a server in a locked machine room in the middle of nowhere, it's going to be hard to get into it and modify the hardware or software physically. But if you have a car parked on the street, or you have something attached to a utility pole, it's going to be easy for an attacker to gain physical access to it and potentially modify it. So that makes security challenges a lot more difficult when you're talking about embodied AI safety.